This talk actually is about a stack that I built at Bitly. I'm currently at Behance, part of Adobe. And talking with our two lovely co-organizers, I realized that it's actually still relevant, which is kind of exciting. And going through this, I realized how much this community has evolved over the past year and a half since last time I gave this talk, and was able to strip out a lot of slides because most of it is now common knowledge, which is also very exciting. I love watching things evolve like that. Some of it's a little basic knowledge because I wasn't sure of how experienced people were, so if you're a React expert, bear with those parts, but they're important. So my name's Erin Depew. I work at Adobe, and we're going to talk today about using Omniscient with React in order to enhance your React app performance. Most of this requires immutable data structures, which is where we're going to start. If you don't know what an immutable data structure is, it's we don't have them natively in JavaScript, which is very unfortunate. It's actually a concept that we borrowed from pure programming languages such as Clojure, Scala, or Haskell. We need to use a library called Immutable.js in order to have access to these, and it really just adds the ability to have pure functions and purity within our app. And also, the most important part for at least what we're going to be working on is we're able to do a reference equality check versus a value equality, which we'll talk about later. I really enjoy functional programming. I really enjoy immutable data structures. I think they have a lot of benefits, even if you're not worried about performance. They allow you to do very cheap value comparisons. They allow to make doing persistent data in the client very, very easy. They make for constant time copying operations in large data sets. You can do multi-threading without locks. You enhance your update speed for also large data sets. And you get less collateral damage from other people on your team or parts of your app that you're not working on. And most importantly, it helps with our virtual DOM creation, speeds that up. There are some drawbacks if you haven't worked with them before. One of them is you do get spikes in your memory usage. The whole point of a mutable object is that you cannot mutate it once you've created it. And that means that we need to copy over all the data before we can change it. So you may wind up with holding two versions of your state at once, and that obviously creates spikes. This makes it much less efficient for smaller data sets and not really worth the trouble. But if you're dealing with a very large application or big data, it's definitely worth your time. And like I mentioned, it requires an outside library for JavaScript, and it does have a relatively steep learning curve if you're used to more of an imperative style programming, which most front-end engineers are if you're coming from a jQuery app or an MVC. So this is the stack that I had built at Bitly. It uses React as a UI and component library and view layer. We layer Omniscient on top of that, which essentially we use to hijack React's should component update function. And then we have to leverage Immutable for those cheap value check comparisons, and Immstruct in order to create basically a mutation and persistence interface on top of Immutable and leverage their cursors. So this is basically your generic React component, which I'm sure most people are familiar with. But the important part is lifecycle hooks that we have available to us. I'm sure most of you know the did mount, will mount, et cetera. The one we're focused on right now is that should component update function. And this is an interesting function. It says in the React docs that it's available to you, but don't use it. So it returns true by default on every single render. If it returns false, it means that you skip every other function in your component and it doesn't re-render the component at all. So if you're an engineer interested in performance and you look at this, you say, I'm brilliant. Obviously, I'm just going to check and see if the value is exactly the same in my props, and then I will return false. You do not want to do that. You will shoot yourself in the foot. I have tried it. It's because, especially at our higher level components, you're dealing usually with very deeply nested data structures. It's usually arrays with objects with more arrays with more objects inside of them. And in order to check if that's actually equal, you're going to need to loop through all of that. And the amount of time you will take to loop through all of that on every render is not worth the amount of time you'll save on that occasional render when it doesn't change. However, we can sidestep this issue if you start using cursors and immutable data, because we get all the benefits of being able to check whether we actually should update or not without any of these drawbacks. But first, in order to do this, you really need to have the idea of unidirectional data flow. So we have, which again, this is probably common knowledge for a lot of you, but if you're using a React app, you should have a unidirectional data flow. Everything flows from the top down, from parent to child. But that app state at the very top should be an immutable structure with an Immstruct wrapper around it. This requires all of your components to be declarative versus imperative. And besides the fact that you can enhance your performance, it's also nice because it means you can do time traveling and state serialization, because it means that you can literally just swap out your app state to re-render your app. And it makes for much easier testing and debugging. So this is just an example of what this looks like. If I have my cursor, I can actually just print out my entire app state at once. And for all our visual learners out there, this is basically what we're doing. So these immutable structures that we're using in order to be able to hijack this should component update function. Like I mentioned, you get a reference check versus a deep evaluation. So what does that actually mean? It means that instead of going through an array and checking each item in the array to see if they're still equal and the entire array is still equal, I merely just check if it's still referring to the same point in memory, same space in memory, and then I know it's the same object. So obviously that's a lot faster than iterating through an array or an object. And when I use Immstruct, it means that I can do cursor.update, which triggers a swap event. And the nice thing about these reference cursors is they always point to the current data. You get apps, so it means stale data is no longer an issue at all. This also helps with that, having that app state and being able to do state serialization as well. So just a little peek of these two APIs because I think they're interesting. And also it's kind of hard to wrap your head around what an Immstruct cursor actually is. So this is the general API for it. We can create a new Immstruct cursor, which is essentially just a mutable object with a few extra bells and whistles attached to it. And we're going to call it structure. We can update it. We do structure.cursor.update, and now it's foo_baz, which is what it'll print out if you call it. We can assign this to a new variable. Now we have new cursor, which still equals baz. We can set another cursor, and we want to update it to foo. And this is where it starts to get weird. So your new cursor will be foo_baz. If you reference that cursor directly, it'll still be baz. The other cursor will be foo, which is what you're expecting, but the original one will also point to foo. What you won't see underneath here is that original, when we first created that immutable object with the Immstruct wrapper around it and the cursor, it's essentially following where that data point goes. And every time you change, it's going to follow that mutation through. Which, as you can see, would be very handy if you have all your state in one place and want to serialize it and want to do time traveling. Immutable is a little more straightforward. I just like it because it makes handling very large nested data structures very, very easy. You can do things like create a map, set things in it. You can set in and travel all the way down deeply into your structure and set one point. You can update in and run it through a function. And of course, the problem I said where you're going to get spikes in memory, if you use Immutable, it also gives us kind of an escape hatch for that. And it's called withMutations. So if you have a data object that you need to hit with a lot of mutations all at once, as opposed to creating such as 3 or 4 copies of something in order to mutate it 3 or 4 times, you can instead call it withMutations, hit it with all of your mutations, and then reform it to an immutable object. And so this will preserve your transactional integrity in your stores, but you still get all the benefits of using an immutable object. So I can run through these probably quickly because now every modern framework uses a virtual DOM, but essentially it's a diff that you create when a user interacts and changes your state, and then you apply it, batch update the actual DOM with it. But most people don't realize that the React knows to create this virtual DOM one of 2 ways. You can either pull your data recursively, which would be terrible, and you shouldn't do that, or you can observe the app state, which is what it by default does. So this is essentially what we're doing. We get some dirty data nodes once the user interacts with it. We compute our diff, and then we render the browser DOM in full. But if we layer Omniscient on top of it, we now have a third option for how to create this virtual DOM. It means that it will get rendered once you set an Immstruct cursor that's set in, it will fire off an event saying, I've been swapped. I've been updated. And that will trigger a re-render on Omniscient. And that central Omniscient should component update now does a top-down re-render. Every single component then handles in its should component update function. It will then go through and check and see if it still has all of its props in the same spot in memory. And then it will return true or false of whether or not it should re-render. And then we do our standard diff created DOM applied. So the big difference here is this middle section. We still have our dirty data nodes. We still compute a diff. But the nice thing is we don't have to observe anything. It's just, it sends out a signal and it creates it. But the nice thing is that in the old version, a parent, all of its children would automatically be re-rendered, which is still loads better than most of the other frameworks and like an MVC model or something like that. But it means that if you have a large application and you have a lot of structures inside of it, you can get some serious performance savings if just the parents changed, but none of the children have. And then you can, so your virtual DOM will be created much faster, and then it will eventually be applied onto the browser. So like I said, for this kind of strategy for how to handle your React app in this stack, there's definitely a learning curve, which is one of the drawbacks. If you're not used to functional programming, if you're not used to working with immutable data, it can be a little tricky to learn. The propagation can get very verbose, especially when working with cursors. And I know I had a hell of a time. I would constantly accidentally dereference cursors, and you learn very fast not to do that. You also find yourself switching between immutable and plain JS a lot when you need to actually put data into the DOM. And then the Immstruct cursor API shadows the Immutable API very closely. So sometimes it can be hard to know which one you're actually working with. They each have one or two features that you need from each of them, so you can't get rid of one of them. But and you also have a static performance penalty with dealing with immutable data objects. So it's not really something that might be worthwhile doing if you have a very small app, but for a larger one, it definitely would be worthwhile. And of course, it has some benefits, because otherwise I wouldn't be talking about it. It obviously keeps things very simple. I like immutable data because I know exactly what I'm working with. It makes checking for state changes much easier, much more efficient. You get much fewer side effects when working with immutable data. You can't accidentally change a variable that you referenced like 3 cycles ago. It makes for much easier testing and easier debugging when you have this immutable state, because then you can serialize your state and send it off to server and replay things. And most importantly, it reduces your re-rendering and repainting of nodes in your DOM, which I guess is kind of the end point of this, is that it creates a much smoother, much faster experience for your end consumer. So thanks, guys, for listening to my talk. Two questions?
What are some examples of work where you've used this before and you've noticed like a pretty significant difference in performance and stuff, or where something was suffering before incorporating this?
Like I said, this was something that we used at Bitly when I was working there, and something I created while I was there. And we had a very special use case in that we were dealing with big data, like big with a capital B and D. And we were dealing with real-time data and large data visualizations and dashboards. So our lovely design team created these beautiful visualizations. They're all over the page, like 6 or 7 or 8, 10 graphs on a page. And you definitely notice that browser slowdown pretty fast when you're dealing with real-time data coming in. So this definitely helped us speed things up and only re-render when we needed to. Because a lot of times things weren't actually changing with the real-time stuff, but it would still repaint it because it was still a child of it. So that's the special use case where I was able to leverage this. I imagine some people are also working in similar situations as we start to consume more and more data, which is why I want to share it. Yes, in the back.
If you have a smaller React Redux app, can you recommend any other libraries that you could put on top just to get a general performance change instead of just doing this whole build? I'm actually not sure. I feel like I've only worked on very large ones. I haven't really been able to dig. When I've worked on smaller apps, I've never been that worried about performance because it's been just for me screwing around. Hopefully someone else might be able to help you out though. I guess that's it. So I'm going to leave this up. This is where you can find me on the internets. Hope to see you afterwards.
Thank you.